see if this spurs any questions. One thing, let me make a point out of one thing I think I might not have made a big enough point about. Here we go. If I have, somebody help me out. Well, let's do this first. Who remembers how to look at this thing here?
How many twos does it take?
Yeah, how many twos does it take to multiply to be 16? And of course the answer is 4. And I want you to realize something. Maybe really just tell you, realize this. A logarithm, of course the answer is always going to be a what? What physically is it? What's the 4? The 4 would be the what on 2? Exponent. So the answer to a logarithm is always an exponent. Today we're going to talk about properties of logarithms. They're going to be the same as properties of exponents because logarithms are exponents. That's almost too nice to believe. So if you see a log question, it's really saying what power does this need to become this? Now, real quick, what would this mean? Why is the answer 2? Yeah, but I want you to realize, this question doesn't know the power. We have to figure out what power. This question doesn't know the base. That's the relationship. Radicals are questions about what does the base have to be if the power is 4 to make 16. Logarithms are all about what does the power have to be if the base is 2 to make 16. That's the connection. That's why there are a lot of kind of similarities between logs and radicals, but they are definitely not the same thing. Yeah, like it. How much do you have to actually know what I just said to be able to do any of this? Nothing about it. But the more you understand the general idea, the easier all the parts become. Darn it, I'm going to try to erase it with this. All right. Oh, I don't need to erase it. So, let me ask you this question then. What is the relationship between f of x equals 2 to the x and g of x equals log base 2 of x? Forgot to get more markers. Oh, look at you. Not at all, but at least right so you can see it. Anybody know the relationship between 2 to the x and log base 2 of x? There's a relationship. There's a word that we've studied not too long ago. How are these guys related? What about cube root of x versus x cubed? What's the relationship there? Cube root of x versus x cubed. What kind of relationship is that? One is the what of the other one? Not conjugate, no. No, conjugate is 2i plus 7 versus 2i minus 7. This is cubing something versus cube rooting something. Those are completely opposite, otherwise known as inverses of each other. These are inverses of each other. If I put, what do I get if I put a 4 in there? What do I get if I put a 16 in here? So the output of one is the input of the other one. They are inverses of each other. In fact, isn't that how we created logarithms? We drew it first, and then we gave it a name. We're like, what did we just draw? I don't know. Let's call it log. All right? And everyone knows it's log. Okay, maybe. So now watch this. Let's see if you guys get this based off of what we just said. Can somebody tell me what this is? First off, can you read that correctly? What does that say? 3. What's that? Read it. What's it say? 3. No, 3 to the log base 3 of w. How does 3 to a power and log base 3, how do they relate to each other? Inverses of each other. What do inverse functions do to each other when they act on each other? Kill each other. There you go. It's just like cubing a cube root. Or doubling something cut in half. Exactly the same. And so if I wrote it the other way around, what if I write log base w of w to the 9th? These two are going to kill each other. And the answer is 9. How you guys feeling? You guys all right? Let me say one little thing and then I'll stop. So for example, anything I give you, 11 to the log base 11, as long as these bases match up, they are opposites of each other. So 11 to the log base 11 of the square root of t. Square root of t. Bam! What does this represent by itself? Oh, that's a weird question to ask, and I don't seem to care. What does that represent by itself? What's a logarithm always? The logarithm itself is always a power. I like it. I like it.
So what does it take to multiply 11?
The power that 11 needs to become the square root of t. That's what that represents, right? What does this represent again? The power that 2 needs to become 16. That's why the answer is 4, because it's the power 2 needs to become 16. So the logarithm statement itself represents the power 11 needs to become this. So what do I get when I raise 11 to it? I freaking get this. That's what the hell I just said. All right, that's a weird way to look at it, and I don't care, because again, that's really explaining the idea in a different way. What's a better way to look at it? A more direct way to look at it? The way we just did. These kill each other. I like it. Okay. Let me see, I want to make this transition smooth. Well, let's do, yeah, we did that. Let's do a couple more just nuts and bolts, and then we get to something new. Let me keep all this stuff straight. This is what I want to do next. Yeah, dude. All right. So, let me tell you something interesting. If I just wrote this, what do we understand this to be?
Square.
There's understood to be a 2 there, right? And why do we do that? Because that's the most used root. We live in California, in case anybody wasn't aware. And things happen like earthquakes. And when I explained this in Virginia, people really couldn't compare to it. But then I can explain hurricanes there, and here you guys are like, I've heard of that hurricane. I don't know what that is. Earthquakes happen here. What do we use to measure the strength of earthquakes? Starts with an R. Richter scale. Richter scale. No? Yes? Maybe? A little bit? Well, the Richter scale is a logarithmic scale. Every time, so the difference between 2 and 3 on the Richter scale is a multiple of 10. It's 10 times more powerful. So for a Richter scale 3 earthquake is 10 times stronger than a Richter scale 2 earthquake. Because those are the powers on 10. It's 10 times as big. That's kind of crazy. That's why they're all like, was it 7.5 or 7.6? Because that's actually a bigger difference than we think. We're like, who gives a shit? No, that's a big difference. Richter scale uses a certain logarithm. How many fingers do we have? 10. All right, so anything that kind of counts on 10s would be the most often used thing for us because we have a base system 10. So if I see something like this, the base is not written because it's understood to be 10. Same way with have a root symbol with no number there, it's understood to be 2. You guys with me? Have you ever heard of something called decibels? Where they measure like the jackhammer versus a rock concert or something, right? Okay, I like it. And basically, some rock concerts sound like the jackhammer. Well, whatever gets you through. Only a Jeff. Oh, by the way, so decibels use base 10 also. Can anybody tell me what this answer is? What are you asking yourself? What's the power that, what's the base again? Understood to be 10. So what's the power that 10 needs to be 10? 1. So what's log 10,000? What power does 10 need? What's 10 squared?
10.
What's 10 squared? What's 10 squared? 100. What's 10 cubed? 1,000. How many zeros does 1,000 have? How many zeros does 1,000 have? 3. It was 10 cubed was 1,000 with 3 zeros. How many zeros are there? How many 10s do you need then? 4. 10 times 10 times 10 times 10. 1, 2, 3, 4. 1, 2, 3, 4 zeros. It's base 10. So you're thinking, well, how many 10s would it take to multiply to be this? So on a Richter scale, 4 somehow relates to a power of 10,000. Right now, we have to talk about what that power means, but that's basically, anyway, I won't go too deep into that. Go too freaky. Okay, there's another base that we need to talk about. This one, I don't really necessarily want to throw this in out of nowhere, but you have to have seen this before you leave this class. It's just the fact. If I threw some rabbits in a room with some food, what's going to happen over time? Just keep giving them enough food and water. Water would be good. I want them to live. Well, of course, rabbits always get picked on about this, but every animal species has children, right? So the rabbits are going to have kids, so forth, right? So the growth of the population of rabbits in this room is going to go up and up and up, right? The more kids, and unfortunately, I'm sorry, but the kids are going to, anyway, we don't get too deep. It's just the way things work. But their population is going to grow from there. And it kind of grows in that shape, and we know what kind of has this kind of shape is an exponential. So it has some initial position here, and then it just goes up from there. The more in your population, the more to have babies, the more babies are made. Then there's more in your population, they're going to have even more babies. And right, the earth is like, shit. Okay, I won't get political and all this. All right. There's a certain base that represents this growth best. And just to cut to the chase, it turns out to be right in between, to be a little specific here, right in between, you can do it, Jeff, right in between 2 to the x and 3 to the x. And this is a number that's just like pi. There's a really cool place this number comes from, not just from rabbit sex, but also from something else that's kind of cool. Let me just tell you what this is, and then I'll give you the other place this comes from. This is the letter E. So E to the power represents population growth the best. If you're going to take pre-calculus after this, you will use that to represent growth and like radioactive decay, because radioactive decay is just this picture turned the other way. You have less and less and less and less and less of something, right? Or maybe it represents bank account through college, or my credit card debt, my bank account went like, all right. The other cool place, I'm so sorry because I know. Anyway, the other cool place it comes from is, just go with me on this. You don't have to write this down. This to me is the more cool place for this to come from. Here's y equals 1 over x. There's a picture of that. How far would I have to go to have this area in here be 1? It turns out that I have to go out exactly e. So this number showed up in several different places. That's one of them. Population growth. There's something about compound interest on your money, which is really boring. But still, it came out from this. Everybody's like, what the shit? This number is freaky. And the number is, let's see if Jeff can remember. 2.718, blah, blah. I can't remember the rest of it. That's about as far as I go, I think. I don't know how close I am. Somewhere in there. So it's sort of like 3.1415, blah, blah. Okay, I don't know if you guys are semi with me. So it's just a number that's between 2 and 3 that's special. Because it shows up in a few different places. So what else have we seen like that? Pi. Pi showed up in a few places. Everybody's like, this is from God. They gave it a symbol. You know, whatever gets them through. But we agree. It's weird. It's neat. So we kept a symbol. E, same thing. A dude named Euler discovered this. He didn't use E because it was his first name, though. It was just the next in his line of variables he was using, which is kind of neat. Sorry, that's enough of that. So you guys are like, history of math now? Shit. Oh my God. How can Jeff make this more boring? Get into history of math, Jeff. All right, I'll stop. So here's the big thing to get from this. E is just another number, like 2, 3. It just happens to be a gross number that never stops, just like pi. I will never write this again for you. I will never write this again. It hurt a little bit to write this. Is everybody with me on this? This is log base E. We don't use this. When you see a triple equal sign, that means definition. It's defined to be this. This is called the natural log. And you might understand why it's the natural log because of the fact that this number represents population growth wealth. It represents natural processes wealth. Okay, so ln means log base E. So, if I put down somewhere ln e to the 7th, based on what we just said earlier, and now we know what the ln base is, what does ln and e do? Cancel each other. They're inverses of each other. Log base e kills base e to a power, so the answer, of course, is 7. Okay, kick ass. That might be enough to give me to put this out to you. Oh, one last thing. I think, did I start with this? I meant to start with this, and I don't think I did. Yeah, I did mean to start with this, and I didn't do it. Oh, yeah, I was building up to it. I never got there. Somebody help me out. Why is log base 2 of 3 equal to, get out there, 3, of 8 equal to 3? Why? Why is that true? Because 2 to the third equals 8. So if I say rewrite a logarithm in exponential form, that's what I mean. How's it done? Always the same frickin' way. So what have I said? Log base W of capital A equals R. Of course it does. So let's just say that's given to me as true. How do I rewrite it? W to the R equals A. Kick ass. So if I say rewrite in logarithmic form or rewrite in exponential form, you have to be able to go between the two of them. So let's see how we do. I want you guys to look at this bad boy. If you decide it says 12.3, don't worry about the 12.4 with the red writing yet.